this, it's still loading. Let's let that load up. Okay, so if you're seeing my screen here, it says, it's basically like, here's a, let's see, you sent over something. Here's a triangle. Polygons are triangles. And we're going to just transform them. Let's see here what you got. Minimum rotation. Well, actually, what you sent me is kind of different than what I was thinking it would be. Oh yeah, yeah. I mean, this is kind of what you're doing, and they're doing some stuff with angles. Okay, I mean, if that's okay with you, I'll just pull up some problems for us to work through. And then, like I said, if you want to switch over to like SAT, ACT prep, we could do that, at the midway point, or totally up to you what we do. So they're in this problem here, they're going to give you an image, some sort of an image, and they're telling you the transformation. They're telling you it's, in this case, it's 1 right and 4 up. Okay, so by now you should know that the right affects the X and the 4 affects the Y. So you can either do it point by point, like we were doing last time in the delta math. Like you can go to that letter B and go, okay, right 1 and then up 4. Okay, that's one option. That's your B prime. Or you can know, okay, to go right, I'm adding 1 to X, and to go 4 units up, I'm adding 4 to Y. So that B coordinate here, right 1 unit will be 4, comma 4. And that's exactly where this new point is.
Okay.
So the in terms of like the language that they're using in there, the original one's called the pre-image.
Mm-hmm.
And then let me just check and see if your notes actually talk about
Yeah.
the transformed image. What named graph the transformation? So they don't necessarily refer to the, I mean, the B prime, the red here is going to be it's not really the post image, but there's kind of pre and post, but it's the transformed one. And you just do this point by point. So in the case of A, you're going right 1, up 4. That's A prime. And you can either write the coordinates, or you can use the +1, +4 for X and Y. Similarly for C, right 1 and up 4. So the prime is always used to indicate the new image. That little asterisk, apostrophe, that's the new image. And I think you've seen that. I think we've even done that a couple of times.
Mm-hmm.
So that's, nothing is familiar. I mean, nothing is new on
Oh,
that.
okay. Yeah.
Okay, now that it can be more complicated than just a right and an up. We can do flips, reflections, over lines, rotations even. So there's quite a bit that can be done here. So let's do, let me see if I can find one more here. Now, have you done any scaling, like made the image bigger or smaller?
No.
Okay. All right, so let me grab a new image here for us. Try this. All right, so here's a new image. And so I'm gonna make this one closer to the examples you have in class. So let's say this first shifts right 1 unit, then it flips over the y-axis, and then it goes down 2 units. Okay, so we're gonna work through that in this problem here. There are 3 separate transformations. Okay, and they usually have to tell you the order. You assume they're in the order that they're given here. So let's just move everything to the right one. So that's A prime, B prime, D prime, C prime. Okay. And then if we want to then flip it over the y-axis, we'll do that in blue here. You figure out how far away each point is from the axis. So I'll start with the B. So the B is up 1, so that B, that new B goes down here. We're gonna use a double prime for that. And then C prime is 2 away below, so it's going to be 2 away above. And then D is 2 down, so it's going to be 2 up. There's D double prime. And then A is 1 up, so it's going to be there. So you can see it gets, you know, depending on the processors, it can really get complicated pretty quickly. And then I'm actually going to not do this last one. I think it's we're pretty saturated on that as far as where it goes. But you can see you can do multiple types of transformations. And so the original, the pre-image is the one that's in the one that you started with is called the pre-image. So the A, B, C, D is the pre-image. And then the one in blue is the transformed image. Let me find a couple more problems here for us to look at, and then we should move to the angle stuff that it's talking about here. Okay, so let's do a new one here. So I'm also going to look for some problems where you have to guess the transformations, which I think is the hardest one of all. But let's do one more together here. So the way this, let me make a couple transformations. So the first one will be a flip over the x-axis, and then we're going to go left 4 units. So you can actually do it all in one step if you want. You could take a point like Q. You could flip it over the x-axis, so it's 3 away. That means it's 3 down. But then you've got to move it left 4. So you go 1, 2, 3, 4 left like that. And that's your new Q position. You can do the same thing with P. P is, if it flips over the x-axis, it would be down here. Same distance away, and then it would go left 4, 1, 2, 3, 4. So there's your P prime. And then S, flip it, it's there, left 4, 1, 2, 3, 4. You can see that that's there, S prime. And then R, when you flip it, it stays on the axis and it goes left 4, like that, R prime. And there's your new shape. Sometimes though, it's hard to tell. It's hard to tell, well, you know, is it a flip? Is it a, flip and then another flip? So let me see if I can find some of those types of problems where they give you the transformation and you have to figure out what's going on. So let me look for those. Image, pre-image, okay. Okay, this will be a good one for us to look at. All right, So like what I was envisioning is a problem like this where they give you the pre-image and then the image. And so we're going from left to right. We're moving from that one on the left to the one on the right. And sometimes it's good to like identify the vertices, like where are they? Sometimes it's also easier if they're on the same graph. So I'll put this one on the right on the graph over here on the left to make it easier to see. Let's see here, and then that one is 1, 2, 3, 4, 5, 6. 4, 1, 2, 3, 4, 5, 6 down 4. And this one is 4 from there. Okay. Okay, so in your opinion, how do you go from the original one to the new one, or the pre-image to the image?
Um,
And here are your options. So your options are first shifts up, down, left, and right. And it can be more than one. It can be, one up, two right, or
4 down.
okay. It looks like, yeah, look, it's maybe hard to count here, but 1, 2, 3, yeah, 4 down for sure.
And 8 right.
Okay, so we'll just count here. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 8 right. Yeah. Now does the order matter? Like if you were to go 8 right and then 4 down, or if you were to go 4 down and 8 right, does that?
No.
The order does not matter. Sometimes it does in these, but not in this one. Okay, so let me try to find one that's a little more complicated. Oh boy. These are not done very often. Like once you don't see them again in your curriculum. It's one of the reasons there's not that many problems out there, and they're hard to make up as well. So just a moment here. All right. Yeah, here's a good one. All right, so here's a problem. So you can go either direction from the well, actually I take that back. It's this one right here. You're going from XBG to the primes. So the primes are always the post image or the image, and the ones without them are the pre-image. So this one's a little harder. Like you're not just going up, down, left, right, but that's always where you start. You always hope for just shifts. You always hope for up, down, left, or right. The next one you sequence through to are reflections
Rotate.
over the x-axis and y-axis. Yeah, like I would hold off on doing rotations as like my third one, and then the fourth ones are the lines. Y equals x, y equals minus x. Those are the hardest ones to see. So rotations, hang on to those until the end, but maybe you can do it with just 1 and 2.
Okay.
Let me know what you see, if anything.
Reflex. It is y equals x.
Yeah, so that actually does work. And I'm laughing because, yeah, like there's more than one option. Like I actually didn't consider that one, and it's like fantastic that you're like, yeah, it's y equals x.
Oh, I didn't see. What?
I actually, so I saw it, and this is what makes this kind of neat, is I saw it as first a reflection over the y-axis, and then one over the x-axis. But oh no, so I take it back. It does not reflect over that line that you just gave me, and here's why. This g, it doesn't match up right there.
Okay.
So that's it's still a reflection, and then that b, would have to match up there. So, but it really looks close. I'll give you a rotation here next. Can you see how it goes over the y-axis and then the x-axis?
Mhm.
Now, could it go the other way? Could it go over the x-axis and then the y-axis?
Yeah.
Yes. Yes. So sometimes, sometimes you can vary the order. All right. Let's look at another one here. Take a look at this and let me know if you see anything there.
Oh, that's a reflection.
Over which axis?
X.
Yes, very good. Okay, so this one is going to be harder than the other ones.
Mm, is it a rotation?
It is. So we got to be more specific though.
91. No.
Okay. Okay. No, that's fine. It can be 90 because it's only moving one quadrant. So it could be a 90. You just have to get the direction right. So there's the clockwise. And then if you go the other direction, that's counterclockwise.
Counterclockwise?
Yeah. Which means it could also be a 270-degree clockwise rotation. Is it clear what I mean by like moving quadrants?
Mm-hmm.
Okay. All right. So actually I found kind of a really nice multiple choice thing here that we can go through. This one's actually pretty comprehensive. Some of them are pretty quick, kind of in multiple choice format though, so we don't have to verbalize these, but let's take a look at these, and we get through all these, maybe we switch to a new topic here. So take a look at this and let me know what you think.
Seven units to the right.
So remember, you're going, which one are you starting from?
Oh, wait. To the left.
Yes. So your start and then your end. And I think that's why this question is here, is to be, deceptive a little bit. You're going this direction.
Okay.
So what's your answer? A, B, C, or D?
D.
Yeah, good. All right, so here's another one for you to look at, think about. If you're not sure, I'd be happy to explain, like, this one's kind of different than what we've been doing, but I'd be happy to explain this.
Is it D?
Did you say B as in boy, D as in dog? Which did I hear?
Dog.
Okay. So the way to answer that, and I believe you're correct, is you start drawing lines. That could be a flip. In case you weren't sure, you wondered how to do this generally. That one works like that. And then if you were
Mhm.
if you use that line as a flip, you could do that. Because you could actually go. So yes, the answer D is correct, but there's multiple answers to this. Like you could actually flip it on its other end up here at the top, or the one on the left.
Okay.
So there's keep that in mind here. All right, so next one here. What I want you to tell me, get it snipped in. Okay, so they want you to read the problem and tell me which quadrant the answer will be in.
Mm, the design.
So there's a it's not a great quilt. It's got one design. There what I want you don't read too much into these. Basically, it's just asking, like, if you transform the triangle 90 degrees clockwise, that's what I was hoping you would focus in on. Which quadrant does it move to?
Oh,
And if it's not clear, this is the first, the second.
the second.
Yes, yes, good. Okay. Now, unfortunately, that doesn't help you much with the answers because all the answers are in the second quadrant. But which one of these is that rotation? Which one of these is that 90-degree rotation? So the one in the lower left is all the same in all of them, but one is the clockwise rotation. And you're going that way. And if you're not sure, tell me which ones it's not. There's two that it cannot be for sure.
C.
Yep, C is out and A is out also. A is just a push.
Is it B?
It is B. Good. All right. These are too easy. All right, let's look at this one here. All right, let me just a tiny bit smaller here. Okay, so it says polygon A will be rotated counterclockwise 90 degrees. So I want you to tell me which is the correct answer for this.
Mm, C.
Okay, and how confident are you in your answer?
I'm not very confident.
Okay, so 90 degrees, you always think of it as it can only move one quadrant. So it's either, the answer is either over here to the left or down. So it can definitely not be C. C's in the wrong quadrant.
Okay.
Okay, now counterclockwise, tells you that you're going this direction. Does that help to maybe?
D.
So it looks very much like it could be D. And I'm gonna say it probably is. That quadrant thing really is pretty powerful when it comes right down to it for figuring it out. Okay, here's a kind of a variation on what we've been doing. A lot of intelligence tests do a lot of these pattern recognition stuff. I don't know if you ever did any testing for that, but they associate patterns with intelligence, whether that's true or not. That's another discussion, but it's not really math, I guess is what I was trying to say. There's not really any math here. It's just, do you see the pattern or do you not?
Reflections.
Okay, I agree. Like it reflects over this line and then this line and then this line, reflections only. Good. Okay. I like this problem. I'm trying to pick ones that you don't have to draw anything because these are really hard to draw. All right, go ahead and take a look at this, please.
-1, -8.
Okay,
See?
and how confident are you in your answer?
I'm confident.
Good. So the reason I asked that is whenever you have these multiple choice tests, one of the strategies is to really have confidence in your answer. You don't want to have any doubt because it clouds your ability to move through the rest of the test. So 4 units down, not a big deal to move it, and it's off the grid. So sometimes students struggle with that, but no, that's great. All right, so we can talk a little bit about regular polygons now. Just do a short lesson on this and give you some more information that you'll probably see in class. So do you know the smallest number of sides that you can have in a regular polygon, or the fewest number of sides?
5.
Okay, so good guess. 5 is a pentagon.
Oh,
There is smaller.
4.
4, that's a square, but they're smaller.
2.
2. So you're gonna have to tell me what is the name of a two-sided polygon? Because I know a three-sided polygon is a triangle.
There's no two-sided.
Yeah, you probably had you could make a fortune if you came up with that one. So one of the interesting things about polygons that are regular, we'll talk about that in a moment, is they have for whatever number of sides they have the same number of vertices as sides, three vertices, 3 sides, 4 vertices, 4 sides, and so on. But what's more important about them is that all the sides are the same in a regular polygon, and all the angles are the same. And you probably know this, but now it's kind of formalized here. Okay, so there's some formulas that govern regular polygons. We're going to look at those now. All right. So the first one is we're gonna make a little table here. So number of sides, and we want to know the sum of the interior angles. So it's pretty not too big of a table. So a 3-sided polygon, we know that's a triangle. And do you remember what all the angles in a triangle add to?
What they add to?
Yes, what is the sum? What is the total of all the angles in a triangle?
360?
180.
180.
Yeah. if it's a four-sided polygon like a square, and they all meet at 90-degree angles, what is 90 plus 90 plus 90 plus 90? You just said it actually.
360.
360. Now for a five-sided polygon like a pentagon. Oh, and you do want to ask your instructor if you're going to need to know the names of these, because after pentagon, you get to hexagon, and that's usually where most students stop remembering. If you're driving, you know that an octagon is 8 sides, the stop sign. This has a sum of 720. So do you see a pattern? Do you see a pattern on these numbers on the right?
They're all like the first numbers, they're all like I don't explain it, like 2 from each other.
Okay, yeah, that's true. So, but that doesn't always work. So you'll see
No.
that here. You'll see that here. What am I adding each time? How do I go from 180 to 360?
You're adding angles.
True. But what number am I adding? What number am I adding to get to this next number? Or what is 360 minus 180? It's another way to. And you're welcome to grab a calculator if you're not sure.
Oh, 180.
Good. What is 540 minus 360?
180.
Okay.
Are all of them 180?
Yes, and that is the pattern. Okay. Now, you're just taking my word for it, and we'll talk about that. So this is a linear pattern. As the number of sides increases, the sum of the interior angles increases by 180. So one of the very first formulas that you learn, and then I usually use S for this, this stands for the sum of the interior angles. Okay, and the formula is number of sides minus 2 times 180. I think that's even in your notes from today. Okay, so this is one of those things you definitely want to get down. It's going to come up again. So let's see if it works. Let's say n is 4. 4 is a square. I want you to put 4 into this formula and tell me what the sum of the interior angles is.
Is this like I'm doing pandas?
Yes.
Okay.
So you're going to subtract before you multiply.
Okay. 360.
Yes. Now, is that what we set up in our table above? Yes.
Oh yeah.
Okay. All right. So now let's do it for an octagon. Stop sign, right? Stop sign is 8 sides. You probably don't look at it very often. I mean, we just know to stop. Thank goodness. There are places in the world where they don't stop at stop signs, so I'm glad we have that in place here. What is the sum? And I want you to use this formula again, the n minus 2 times 180.
Mm. $1,116.
Try again. It's a nice number. So you're going to subtract 8 minus 2 times 180.
Um, oh, 480.
Are you using a cell phone calculator?
Yeah.
Okay.
Well, I'm doing it.
So let's
like
just do
separately.
some mental math here. 8 minus 2 is 6. And I just want you to take 6 and multiply it by 180. That's all. Clear it out. 6 times 180.
I'm so confused.
Okay. I just want you to multiply 6 times 180 for me.
Oh, okay.
That's all. Yeah. I'm not trying to make this any more complicated.
It's 1080. Let's see.
1080, right? 1080.
Yeah.
Okay, good. And that's what we would have gotten here if we would have kept going on this table. Now, all of these have names like the triangle, the square, the pentagon, you probably know, hexagon. You want to check with your instructor and find out, like, are you going to have to memorize the names? Okay. And here's why. Okay. Because I'm going to give you a new problem here. I'm going to say, what is the sum of the interior angles for a decagon? Okay, so there's no numbers in this, which means you have to know how many sides are in a decagon. Okay, and I'm going to tell you, but that's the reason you may have to know this. Okay. Now, any idea what the word deca does? That might be a helpful hint here. Any idea what that refers to?
No.
So deca, you can think of it as short for decade. So that's 10, n equals 10. Okay. So I want you to use this formula and tell me the sum of the interior angles. So 10, you're going to subtract 2 and then multiply by 180.
$1,440.
It's 1440. Good. Okay, now it's a reasonable question to have, or to at this point be like, well, why would I ever want the sum of the interior angles? Like, why would I ever want to know the sum of the interior angles? And the answer is you don't. You do not want the sum of the interior angles, okay? But you need it for the next step. So we're going to make one more table here. This is the number of sides. This is the sum, okay? So for a 3-sided polygon, the sum is this formula, n minus 2 times 180. It ends up being 180, okay? Now what we're going to do, we're going to add to this table, and we're going to find the interior angle measure. Okay, so to get the interior angle measure, you take the sum and divide it by the number of sides. So can you tell me what 180 divided by 3 is?
60.
60. So in a triangle, in a regular triangle, when all the sides are the same and all the angles are the same, the angle measure is always 60 degrees. And you probably remember that that's an equilateral triangle. Okay, now let's do it for a four-sided polygon. You already told me the sum is 360. What is 360 divided by 4?
1440.
You're dividing 360 divided by 4. I think you multiplied.
Oh, 90.
90. Now, what does a 90-degree angle look like?
Like a corner. Oh, rectangle.
Yeah, or square, right? Because all
Yeah.
the sides are the same.
Square.
Okay. So in a regular polygon, all the sides are the same, but so are all the angles. Okay, now let's go to a 5-sided one here. This is the first one that doesn't work so well, but we'll still do it. What is 540 divided by 5?
108.
108. So here's what that means in a pentagon. It means that each of these angles is 108 degrees. Okay, that's what's going on there with that one. All right, so let's do it for a 6-sided one, which is a hexagon, 720. Can you tell me what each angle measure is inside a hexagon?
120.
20, which means each of these is 120. Okay. So here's what we've got so far. And this table continues forever, but here's to summarize what we have so far. The interior angle. I'm sorry, let's back up here. The sum of the interior angles is n-2 times 180. Okay, that's this middle column that we've been calculating. Okay, to find the actual interior angle, you take the sum and divide it by the number of sides. So what some textbooks will do is they show you the formula this way. The sum is n-2 times 180, and they show it as division by n, like this. Okay, so let's do one example problem. So if you recall, I previously asked you, I said, what is the sum of the interior angles of a decagon? So we did that just a few minutes ago. Now, instead of the sum, I'm just going to ask, what is the interior angle for a regular decagon? So in this problem, what it's implying that you do, it's implying that you first find the sum, okay, and then divide by the number of sides. Or you can just use this formula here. Okay, so if n is 10, that means you're putting 10 into this formula here. So I'm sorry I didn't do this sooner. I'm gonna put this in the chat. This is actually an app as well. This Desmos Scientific. It's way better than the calculator on the phone because you can do it without order of operations to answer it. You can either go to the website or download the app, and you can actually enter it like exactly like you see, so that you don't have to worry about order of operations. But could you give me the answer to this?
Where's the goodness. I'm trying to zoom in this screen, but I can't see it. 144.
Yeah, perfect. Perfect. Very good. Okay, so a couple formulas to remember here. I'm going to actually stop sharing here, stop the recording here for a moment.